Okay, so welcome Susie and welcome Casey. Just two of you so far. We might get some more, but I know with the test that just happened, some people are a bit tired, but hopefully you'll pick up the steam in the next few days. The plan today is I'm going to talk about chapter 10, which is a lighter chapter, and I do that because you had the test this week. So it's a lighter chapter. So there's a little less to talk about in chapter 10, especially if you understood chapter 9. Chapter 10 is basically the same thing with a couple little extra details. And then after that, what we're going to do is we're going to get into the project. So we have project 2 happening. And since project 2 is based on chapter 10, I needed to wait until today. And also it's good to let you have time to study for the test before you start thinking about the project too much. I talked about it a little bit last week, but now it's going to be more. So a couple announcements. First is that the midterms are coming in quickly. So this is a big stack of midterms to grade, which I'll be doing over the next couple days. So I should have it by Friday, maybe, but tomorrow, depending on how my day goes. I have some meetings, but I might be able to multitask during the meetings. We'll see. So that is the plan for the rest of the week. And hopefully you guys did okay. Again, I haven't looked at everything, but we'll find out. And I'll definitely let you know in not too much longer. So are there any questions at all about anything? Susie or Casey? It's just the two of you, so don't be bashful. Okay. And also we have the having it on Wednesday is unique. We haven't had it on Wednesday yet. That might be harder for people, I don't know. Next week I'm almost certain we'll have it on Tuesday, and that's because I try not to have a webinar on the holiday, and Monday's a holiday. So it's Veterans Day. So we'll probably have it on Tuesday next week for the Chapter 11 webinar. Okay. If that works for people. Again, I'm always happy to take requests, but I try not to make you guys come during the holiday. Okay. Thanksgiving, same idea. Is I'm not going to have a webinar on Thanksgiving evening. That would be ridiculous. Okay. Since I'll be eating turkey. Okay. Any questions? Okay, so let me share my desktop. I like to go to a current event and use new stuff because you guys watch the videos which have old stuff or read the book, and I like to bring in stuff that just happened in terms of polls and stuff. It's, by the way, we don't need to do the election stuff anymore. Why don't we need to sample things about the election? Why is a hypothesis test about the election ridiculous at this point?
Well, there's nothing coming up.
Yeah, the election was over yesterday. Happened yesterday. So we have a census now. We know everyone who voted. Okay. And the interesting thing in my face-to-face class, one of my students, Tamara Wallace, actually won.
Wow.
She's going to be a city council member. So.
Wow.
Yeah. So one of our city council members will know statistics. Which is a good thing. She's in the face-to-face class, but good person, and she's going to be our city council member. I'm not in the city, so I wasn't allowed to vote for the city. Okay, so let me share my desktop. And this was a nice little article, kind of interesting. And it is, most Americans accept genetic engineering of animals that benefit human health, but many oppose other uses. Okay, so always interesting. This is a big up-and-coming thing, the whole genetic engineering idea. And the question is it okay to use genetic engineering if it helps us in terms of our health? Sounds like a good thing. And what I want to find out is there a difference in gender? Is there a difference in men and women in how they think whether or not genetic engineering is okay to promote human health, to benefit human health? And so that's the question I have. And I'm going to scroll down a bit. And I'm just going to use this first one because it's interesting. And that is mosquitoes to prevent the spread of disease by limiting their reproduction. Okay, so is that okay to do? And 68% of women said yes, 72% of men said yes. Okay, so the question is, can we create a hypothesis test that compares men and women? Any questions on that idea?
We're expanding.
What's that?
We're expanding.
Yeah, we're now doing
with
comparison.
men and women.
Yeah, and that's a big thing. Again, chapter 10 is just like chapter 9, but now we can talk about this versus that.
Mm-hmm.
And in this case, it's going to be men versus women. Any questions on that? Okay, so I want to note a few things. One is that for the women, it was 68%, and for the men, it was 72%. And also, I'm not going to scroll down for you guys, but I looked at it before I started today, and there were 1,272 men surveyed, 1,265 women surveyed. Okay, by the way, is that a good sample size or is that too small?
It's good.
Yeah, over 1,000 is kind of the gold standard for good sample sizes for yes-no question. And notice this is a yes-no question. The survey question is, do you agree with limiting the reproduction of mosquitoes to prevent the spread of diseases? And the answer is yes, I'd agree, or no, I don't agree. Any questions on that? So the next thing we do is we're going to start writing our null and alternative hypotheses. Any questions on that? All right, so I'm going to go and write them down. Okay, so we got our hypotheses that we want to do. Just a minute, let me make sure I can see chats in case they happen. And let us figure out what the null and alternative hypotheses are. So the first thing, oh, I see what the problem is. I wonder if I can do this. There it is. Okay, there we go. So we have H naught. And since it's a yes or no question, and there's men versus women, then we're going to have two different proportions. The first, let's call it PM for proportion of men, and that is equal to PW for the proportion of women. And that's what H naught is it's the same. Whether you're a man or a woman, you have the same proportion, same probability of saying yes to the survey question. And then H1, so the question I asked is there a difference between the two? So that is going to be PM, and I need to hold off on saying it for now because I can't type it. Now I need to go to how do I move this thing? Just a minute. That's how I do it. There we go. There. So because we want to find out if there's a difference between men and women, we're going to use a not equal to sign. So proportion of males is different than the population proportion of women who thinks that it's okay to genetically engineer mosquitoes so that we can decrease the production to help the health of people. Any questions on that? Is that clear so far?
Mm-hmm.
Is it starting to look just like what we've done before, except now we got a PM and a PW instead of just a P?
It's starting to look like the articles we went through from the discussion last week.
Yeah, yeah. Something I didn't mention is that last week really was a gentle walk into hypothesis testing. not all that useful because most of the time you don't just look at a single population. Most studies are comparison studies.
Hmm.
Does that make sense?
Mm-hmm.
And now, after this week, we really have power, and that's why Project 2 is going to be on this week's stuff. Okay, but the ideas are the same as last week. There's just some new details. Okay, our level of significance. First thing, probably since this is just an opinion poll, 0.05 sounds right. Because polling kind of stuff, you usually just do a 0.05, social sciencey stuff. Any questions on that? Okay, so now what we need to do is we need to use our calculator. So I'm going to do a new share. And let's go to our calculator. So for this one, we go to stat. Then we go to tests. Okay, so this is different than last week because we have men versus women. So any guess on what the test we're going to use this time?
2 prop Z test.
Yeah. It's 2 because men versus women. Prop because the survey question is a yes/no question. Z because the sample size is large enough. Okay, so if you look at the number of yeses and you look at the number of no's, they're well over 5. Right? We had over 1,000 men and 1,000 women, and we're talking about like 68% of that or 32% of that, and that's over 5, so we can use Z. You can use the normal distribution. So I'm going to go to 2 prop Z test. I hit enter. And now I got to write down the number of yeses for X for men. And I told you it was 72%, and there were 1272. So 0.72 times 1272. And you need to round because you can't have like 915.84 men. So instead we do 916. N1 was the number of men, which is 1272. Oops, 1272. X2, that was 68% of 1265. Which is 860.2, so we round 860. N2, that was a number of women, and that was 1265. Okay, we're doing a not equal to. That was our alternative hypothesis. And then go to calculate. Any questions so far? Okay, notice a test statistic here is Z. And that's because we're using the normal approximation. And that's 2.21. And the p-value is 0.01 about. Any questions on that? Okay, so now that we have our information that we need, p-value, that's the biggie, was equal to 0.01. Okay, now how do we use that p-value to make the conclusion?
We compare it to the alpha.
Right. And what is the conclusion if we have a p-value of 0.01 and alpha is 0.05?
Smaller.
Yeah, it's smaller. So the conclusion is?
We reject the null.
Yeah, we reject the null. So the good news, as I mentioned, nothing's different from last week. Are you noticing that?
Yes.
Okay. This really is just one extra detail. Okay. We'll have a couple new details that come up soon too. when we do quantitative. But I want to start with the proportions. So what we can do, let's make this a little smaller. I'm going to run out of room.
Casey, feel free to interject here. I want to.
Yeah, Casey, talk all you want. There's only two of you. I would drop you. In fact, you don't even need to mute unless you got like, you're at a concert listening to like hard music or something. But feel free to chime in. There is statistically significant evidence to conclude that and remember the two words that you have to have is you have to have either population proportion or all for when you're doing proportions. For mean, you have to have population mean. That the proportion of all men who are okay with genetically modifying mosquitoes now the hard part, how do you spell mosquitoes? Mosquitoes. Oh, I lost it. Just a minute. There we go. Mosquitoes to help our health is larger. Sorry, is not equal to, is not the same as the population or as the proportion of all women who are okay with it. Any questions on that? Questions? Okay, notice that you got to have the word all or population proportion or you're not referring to the whole population. Any questions?
Yeah. The wording is a little different as we'd expect it would be because now we've got this new element. So it looks more like it's stacking up men to women as opposed to stacking up H1 with null.
Okay, so let's look at H1. H1, if you read it, says PM not equal to PW.
Okay.
PM is a population proportion of men who are okay with modifying mosquitoes. PW is a population proportion of women who are okay with it.
Okay.
So I just stated H1.
Okay.
The proportion of all men who are okay with it is not the same as the proportion of all women who are okay with it.
Which is exactly what H1 is saying.
Exactly.
Okay.
And whenever you write down your conclusion, you're basically writing down H1 and either saying you have statistically significant evidence or statistically insignificant evidence.
Okay.
But it's a good question. Good question because
I'm still trying to wrap my head around these phrasings.
Yeah, there's a lot of writing in this class. You noticing that? It's not like other math classes, that's for sure. So any questions? Any questions on this? Okay, I want to talk about the next idea. And now we want to talk about quantitative data. There are two ways of dealing with quantitative data. One, or two types of quantitative comparisons. One is when you have what's called paired data. So that would be like if you did a survey and you asked everybody two questions that were quantitative. So I might ask people in the class, okay, or people in classes, how much time do you study for your statistics class? And then I could ask a second question, how much time do you study for your other classes? And I want to find out if there's a difference between the amount of time people study for statistics versus others. Is that clear?
Mm-hmm.
The main thing is the same person was asked two questions. So when you're doing that, we call it a dependent sample, because it's one person answering two questions. And what you can do is you can subtract the two answers and see if you get 0 or not. And then you go back to only having one sample. Do you see? Because you have the sample of differences. Any questions on that? Okay, now it doesn't have to be people. So for example, if I wanted to find out if there is more precipitation in Sacramento than there is in San Francisco. Does that make sense? Mm-hmm. And what I can do is I can look at, say, I don't know, 50 days of the year and look at the precip amount in each of those places. So now we have one day with two different cities. So that's dependent also. Any questions on that?
I'm sorry, can you repeat that about the days? I thought you said 50 days and now it's one day.
Yeah, right. So each day, each of those 50 days will have two data values. The Sacramento data value and the San Francisco data value.
Okay, thank you.
So it's just like asking every person two questions.
Okay.
Okay. Similarly, you could do say a survey on husbands and wives, and that's the same thing because you got your couple. So if you want to compare men and women, if you could do it with husbands and wives, then you have dependent samples. Whereas independent sample is when you truly have two different populations. There's no relationship between the individual people. Okay, so that would be things like if I wanted to find out whether people in New York spend more time in their cars than people in California. Now, there's no way there's any kind of pairing. You're going to ask a bunch of people in New York, and you're going to ask a bunch of people in California, how much time did you spend in your car this week or something. Does that make sense? Mm-hmm. So there's no pairing. So that would be independent. So one of the hardest parts about this whole chapter is to be able to decide whether it's independent or dependent. Okay. So let's do some examples. So I'm going to have to get rid of this guy. And let's pop in an example. And I'm copying and pasting a table, so it may not copy in well, but that's all right. Oh, actually it did. Looks pretty good. This one did better than they usually do. Okay, so a manager wanted to see if people spend more money in her gift shop if they're given a free piece of candy when they enter the store. Okay. Is that the kind of thing you've seen in stores, but by the way?
Truckee.
You see it in Truckee? Yeah, you go in and they give you some candy or they give you something, right? And the idea is they're not just giving you free candy. They've figured out, hopefully, that people will buy more stuff in the store if they're given something, like candy. Okay, so below are receipts from 12 customers who were given candy and 12 who were not given candy. Okay, so the first question I have, is this dependent or is this independent?
I think it's dependent.
Why do you think it's dependent?
Because whether or not they're buying candy to see if it's dependent on if they're given candy.
Okay, so it turns out it's independent.
Oops.
And if you look at the people, this first person given candy who said 25 and this first person not giving candy said 37, they have nothing to do with each other. This isn't a husband and wife kind of thing.
Okay.
Just a group of 12 people giving candy and a group of 12 people not giving candy, and they're different 12 people. Does that make sense?
Mm-hmm.
Any questions so far? Okay, so that's the most important thing. Again, it's the biggest confusion is to be able to look at it and say, hey, this is not paired, this is independent. that clear?
Mm-hmm.
So now what we need to do, and you're used to this, is we need to write down a null and alternative hypothesis. So we have H naught. And here we're looking at a quantitative variable, right? Because the survey question is how much money did you spend? And you can see the data are numbers, not yeses and nos. Is that clear?
Mm-hmm.
So when you have a quantitative, we're talking mu and not p.
Mm-hmm.
So you can do, let's say, mu c equals mu n. Any questions on that? Okay, then H1 is mu c. Always starts the same. And now we want to find out if they're given candy, do they spend more money or not? So mu c is greater than mu n. Any questions on that? Clear so far? Why is it greater? Okay, the reason why it's greater is right here. The word more. Casey, does that make sense? Yeah, so you always want to, sometimes you can miss one little word, but every little word is important as you're kind of getting used to, hopefully. So you got to go find, you got to search for that word that's going to tell you. And I don't give you trick questions. The word is there. You just have to really search and find it. Okay, so now what we want to do is we're using a level of significance of 0.05. We're going to go to our calculator. So let's do that. So here we have data. So I have to go to stat, edit, get rid of whatever else I used to have. Hopefully you know how to clear out data. We're going to need an L1 and an L2 this time because we have those giving candy and those not giving candy. Okay, so L1, the numbers, let me go find them. There we go. The numbers were 25, 14. She always does that. 1, 4. But you have to really hit it hard. And then 160. That person spent a lot of money. And then 98, 55, 18, 29, 44, 91, 83, 17, 32. And for L2, we have 37, 51, 40, 37, 40, 22, 21, 9, 30, 28, 19, 11. Any questions so far? So this you're not used to going in L1 and L2, but we got 2 samples now. So then we're going to go to stat. We're going to go to tests. What test do you think we're going to use now? What's your guess?
Is there a 2T test?
Mm-hmm.
4?
What's it say? Yep.
2
sample t-test.
Test?
Because it's 2 samples. Whoops. 2 samples and T because we're doing a quantitative data here. We have data, so you enter data. List L1 is correct. List 2 is L2. The frequencies are always 1 and 1. The next part, a lot of people have trouble with this. And you think about this. Is it a less than or is it a greater than? Well, here we want to show that candy is greater than none, right? So this is going to be greater than. All right, so here's something I just want you to kind of think about, and this will help you remember forever, hopefully. Okay, imagine it's wintertime. I know right now it doesn't even feel like winter, but let's imagine it's wintertime. And there's an outdoor pool in the middle of Lake Tahoe. Do you want to jump in the pool? What do you think?
No.
No. Okay? So in this class, never jump in the pool. Got it? So just say no to pools. Can you do that? If you do an advanced statistics class, then it could occasionally be yes. But I'll tell you, in my experience, I've had lots of experience in consulting and statistics and in real world stuff. I've never pooled anything. So I don't teach pool because it's not really useful. So we're just going to say no to pool. Can you remember that? Mm-hmm. Color I don't care about. And most of your calculators don't even have color. I hate calculate. Okay, any questions on that? What's the most important number?
P.
Yep, P, because that's a P value. Okay, the second most is T, that's a test statistic, 2.006. The P value is 0.03 about. Any questions on that? Okay, so notice now P was equal to 0.03. What's the conclusion?
Less than. Reject the null.
Right, reject the null. So let's write it out. So there is statistically significant evidence to conclude that, and here's a word you have to have, the population mean. Amount of money, or yeah, amount of money spent in the store is larger for those given candy compared to those not given candy. Any questions on that? Any questions? Okay. Notice this is something you care about as a manager, right? Because if people don't buy more if they're given candy, you're not going to waste your money on giving candy. Does that make sense? Mm-hmm. If you find out people do buy more, yeah, you're going to make sure you give candy. So whenever you make a managerial decision, you have to run your statistics and find out if it was the right decision or not. And if it's not, change your mind. Change that decision. Does that make sense? Mm-hmm. And not just for management and business, but in pretty much everything that you do career-wise. Whether you're doing it for health and trying to help people out, is it better to have this treatment or not have the treatment in terms of, I don't know, number of days to get healed or whatever it might be. You do this hypothesis test to decide whether you want to continue with it or not. Any questions on that idea?
I don't have a question about that idea, but I do have a question about the T value.
Mm-hmm.
The Z tells us the number of standard deviations.
Uh-huh.
The T is an adjusted number because we didn't have the population standard deviation.
Mm-hmm.
But But does T also tell us the number of standard deviations, but adjusted, or what is it telling us?
Yeah, let's do that. You know me, we got to draw a picture. It may not be obvious, this is not a normal distribution, this is a T distribution. So I'm going to put a T right here. Okay, by the way, 0, when you're looking at the T value, you're talking to 0 there. And we got 2. Okay, so the question is, does that tell you it was 2 standard deviations from the mean? The answer is not quite.
Okay.
The reason behind all of that is very hard.
Okay.
Okay, you have to understand limits of series of gamma functions. So trust me, you don't even want to know. Does that make sense?
It does.
Yeah.
But I just want to make sure.
Advanced, like graduate school mathematics, not even undergrad.
So it is not accurate to just try to treat it as though it's a z-value.
No, but one thing you can do is that if you have a pretty large sample, T and Z are very close to the same.
Okay.
And that you can remember. That's not too hard math-wise, right?
Yeah, right.
And the word very close, of course, I'm not going to go there because that's really hard. But you can imagine what very close means. How's that?
Okay.
Visually, you won't be able to tell the difference. That make sense?
Mm-hmm.
But it's a good question because it's a tough one. And I pretty much throw all the mathematics under the carpet because being a graduate student in mathematics is not a requirement of this class.
Good.
It's rough. Okay, but you can trust me. How's that?
Fair enough.
Okay, but so the picture does look like this.
Okay, thank you.
I want to mention one more thing. You should never do a study like this. What's wrong with it? What's wrong with this study? You only do this as an example in class. You should never do this.
N is too small?
Yeah, your sample size is 12, and you should never use a sample size as small as 12 and trying to do statistics. Does that make sense? Okay, and in fact, what do you really need to be able to kind of do your stats as a minimum? Do you remember?
30.
Yeah, 30. 31, actually, in our class, but 30 is not that bad. Does that make sense? Okay, the only reason why I did it with 12 is I didn't want to type all day in the calculator with a bunch of numbers forever. I didn't want to waste your time. Any questions on this example? Okay, I'm going to do one more example before I talk about the project. It's got to let me do it. Whoa, what happened? Try again. There we go.
I'm sorry to interrupt, Larry. Where does it being independent or dependent come into play?
Let me give you the next example.
Okay.
Yeah, that's why I'm doing one more example.
Okay.
Okay, and we'll get there. Okay, so here's the next example. Are people better listeners if they do not have use of their eyes? Okay, 12 volunteers. Again, 12 just because I don't want to type too much. Normally you do more. Were first given 100 words to remember while they were looking at the person speaking. Then they were given 100 words while blindfolded. Each time the participants were asked to write down as many of the words as they could remember. Okay, typical psychology kind of experiment, right? The table below shows the outcome of the study. Okay, so the first question I have, is this independent or is this dependent? What do you think? And Casey, you can chime in too. least you got a 50-50 chance. Hopefully a little more than 50-50. Yeah, this one would be dependent. This would be dependent. And the reason is you have this first person, and you're going to watch to see how many they can get when they're looking and how many they can get when they're blind. They're basically answering 2 survey questions. Does that make sense? So each person is answering 2 questions. How many questions did you get when you, how many words did you get when you were looking, and how many words did you get when you were blind?
Okay.
Any questions on that?
Going back to the candy one, some customers were given candy, some weren't. So 2 completely different people. That's why that's
yeah, exactly. There's no
Thank
parent.
you.
This wasn't one person giving candy and then not giving candy.
Okay, thank you.
You see that? Right, as a business person, you can't do that. You can't kind of give them candy and then give them candy. It doesn't really make sense. Do you see? But this experiment, you definitely can do both. Okay, so now let's do the calculator. And this calculator is going to look a lot different than this calculator process. So let me go to New Share and calculator. All right, so the first thing I do, you're used to, it's going to start looking the same. Pop in my data, get rid of the old stuff. And then L1, I got to start typing 14, enter, and then 23, enter, 15, enter, 37, enter 4, enter 3, enter 19, enter 22, enter 51, enter 37, enter 18, enter 16, enter 22. Now let's go to while blindfolded. Okay, and that's going to be 17, enter, and then 25, enter, 20, enter, 37, enter, 3, enter, 29, enter, 24, enter, 53, enter, 35, enter, 20, enter, 19, enter, and 22, enter. Uh-oh, I think I missed one, because they should have the same number. So let me read this again. 22, 19, 20, 35, 53, 24, 29, 3, 37, 20, 25, 17. Do I have an extra one on the next one? 14, 13, 15, 37, 4, 3. Ah, that 3 shouldn't be there. That 3 is supposed to be 19. 22, enter, sorry about the typo, 51, 37, 18, 16, 22, and then clear. That last one shouldn't be there. Did it let me do it? Didn't let me do it. This is the one you can do delete, actually. There we go. It's the only time you hit delete, and don't want to even get used to that. Okay, so now what we don't want is we don't want L1 and we don't want L2. We want the difference between the two. So for example, 15 minus 20 will be the difference between the first person's remembering words with and without sight. Does that make sense? Now I could individually do the subtractions, but I don't have to. The calculator will do it for me. So I'm going to go to the following and quit. And then I'm going to go second one, that puts in L1, and I'm going to subtract L2, second 2. And I'm going to store that, that's STO, into L3, and that's second 3. Any questions on that? And what this does is it puts the differences into the column L3, and I hit enter. Those are all the differences. Okay, something I didn't do and I want to do now, because I was supposed to, is I want to go back. And I didn't write H0 and H1. So let's write those out. Actually, I need a brush. So H0. Okay, what I'm now doing is I'm not looking at just looking or just blind. I'm looking at the differences between the two. And notice I had, when I did that store into, that gave me a new set of data. I'm going to call that data the data of differences. So that's mu sub d. And if they're the same and I subtract, I should get 0. So equals 0. Any questions on that? And H1 is mu sub d. And now let's think about it. We want to see if people are better listeners if they're blind. So for example, this first person who did 14 looking and 17 blind, was that better blind?
I'm sorry, what was the question? Is it what?
Was it better being blindfolded?
Yes.
Yeah. So that's a good example. I like to use an example. If I subtract 14 minus 17, because that's what I did in my calculator, I get -3. You clear with that?
Mm-hmm.
In particular, that was something that we're trying to show. It looks like that. So in particular, it's less than 0. I like to use an example and then see is it greater than or less than, or maybe not equal to if it's a different question. Any questions on that? All right, so I need that. Now I'll go back to my calculator. Okay, so now I'm going to go to stat, and I'm going to go to tests. And the interesting thing is, since we're taking the differences, we just have one column of data, right? Mm-hmm. We're basically back to chapter 9. Mm-hmm. We just want to find out if that column is, on average, less than 0. So because of that, we're just going to do a good old regular t-test. That's the one column test. And I hit enter. I have data. mu0 is 0, because that's on the right-hand side of the H0. Our list is not L1, it's L3. Any questions on that? Then frequency is 1. We want to see if these differences are less than 0. And I hit calculate. And there we go. We have a small p-value again. So I guess today's the day of rejecting the null hypothesis. Any questions on this? If I went too fast, let me know. All right, so now I can type in my conclusion. So I want to go to that one. So now I'm going to go text. So our p-value is small. Hopefully at this point you know what to do with that. And we can say there is statistically significant evidence to support the claim. Notice we're not proving anything. Never use the word prove in this class. That's a dangerous word. That The population mean number of words remembered while blindfolded is larger than the population mean number of words, WORDS, remembered without a blindfold. Any questions on that? Okay, I want to give you a warning. It's really, really important that you don't just say, I understand it, and then move on. Make sure you practice writing these out. Promise that?
Learn that the hard way.
Yeah, watching me do it is not the same thing as being able to do it yourself. Okay, it's good to have examples that you got to watch, but if you don't write them out yourself, you're not going to get this stuff. Yeah, so when it's dependent, you use L1, L2, and L3. Yeah, not usually, always. So you do L1 minus L2, stow into L3, and then you use your L3 for the t-test. Does that make sense, Casey? Yeah, so that's just, I'm showing you the technique, and this always works in your calculator. I'm going to show you something different, though, for the project, because projects, you're not allowed to use your calculator. You have to use your spreadsheet.
Okay.
So are there any questions about chapter 10 before I talk about the project? Okay. I think I mentioned the project last week a little bit, didn't I? Or not? I thought I talked a little bit about it. But now we can talk about it in full detail because we've had chapter 10. At least we've had the webinar for it. So let me go to a new share. Actually, while I'm here, let me cancel that. Let's just go back to where I was. Let's see, that one. Okay, this is probably a good time to give you a secret word. So let's do that. Text. I think I'll do it in green. So the secret word of the day is paired. Because if we have dependent data, that means there's a pairing with each of the couples. Does that make sense? Mm-hmm. So you can pair the first with the first, the second with the second, et cetera, et cetera. So the secret word of the week is paired. Okay, now I'm going to do a new share. And let's go back here. But there we go. Okay, I don't want discussions, I want modules. Or just syllabus, I think is a faster way. Go to syllabus. If you go to syllabus and you go to project 2, notice that it's due on November 18th. Okay, so that's, when is that, by the way? November 18th?
See.
Yeah, it's a week from Sunday. By the way, why didn't I give you one more week? There was actually a very specific reason. I thought about it. Seems like I could have been nicer and given it, had you do it on November 25th instead. What's wrong with that? Huh?
Last week you mentioned something about Turkey Day.
Yeah, Thanksgiving. And I don't want to ruin your Thanksgiving. Sounds fair? So it's due next Sunday. So it's a week from Sunday. So that the next week is a lighter week. You don't have any major stuff due. There's little stuff, but no major stuff. and then you can actually enjoy your Thanksgiving. So you're going to need to get on this project right away, basically. All right, if you click on Project 2. Okay, so the purpose of the project is to use confidence intervals and hypothesis testing. Okay, so just to know, this project is not Project 1. It has very different emphasis. It's all about confidence intervals and hypothesis tests. Okay, it is a Chapter 10 project, basically, but remember, Chapter 10 uses all the rest of the chapters, okay, especially the newest chapters, 9 and 8. So it's going to be a confidence interval for two means, the difference between two means, and a hypothesis test for the difference between two means. Does that make sense? You can decide whether you want to do dependent data or independent data. That's up to you in terms of how your survey should be. If you have a choice in terms of, you know, best practices, dependent is better, but only if you have a choice. You don't always have a choice. Any questions on that so far? Okay, I didn't write this in, but basically the same idea. You want to identify a client. In other words, if nobody's interested in what you're doing, it's not a good project. Okay, someone better be able to use it. Does that make sense? That's kind of the point of the client, is to make sure that you have a project that's worthwhile. And especially in this one, it's much easier to make it worthwhile because doing a confidence interval and a hypothesis test for the difference between two means is very, very useful. So one of the main differences between this project and the last one is a big focus of the last one is your sampling technique. And I told you you couldn't use convenient sampling. It had to be stratified or clustered, remember? Mm-hmm. And it had to be a survey of people. This one's not like that. This one, you have to collect data. And I don't really care how you collect data as long as you tell me how you did it. Does that sound fair? Mm-hmm. It doesn't have to be a survey of people. So for example, you can go and find out some of the measurements that have been taken in our lake. Okay? I forgot whether you guys live in Tahoe or not. Do you?
Yes.
Yeah. And Casey, you live in Tahoe? Okay. Whether you do or not, okay, you don't. So Casey, you may not understand this quite as much, but if you live in Tahoe, our big thing is making sure our lake stays blue. Okay? If you've been to Tahoe, then you'll understand why. Okay? So they do all kinds of protections, and they collect samples and do data, and you can get that data. You can find that data and do a study on that. No, you're not asking any people a survey question. You're collecting data. So you can look to see, for example, say turbidity samples from last year and turbidity samples from this year. Does that make sense? Mm-hmm. If you don't know what the word turbidity is, that's just fine, but just trust me, that's an important one. Okay? Or nitrate sample, nitrate concentration is another one. Okay, so it doesn't have to be asking people a question. It can be if you want to, but you don't have to. The other thing is you could either do paired or you could do independent, but it has to be quantitative. Is that clear? Mm-hmm. So your survey question and the data you're collecting has to be numbers, not yeses and nos. And that's what quantitative is. Is that all right? Another requirement, I don't know if I wrote it in here, but this is an important one, is that if you can get a hold of the entire population and get the data for that easily, then it's not a good project. Because you would never do a confidence interval and a hypothesis test when you know the whole population. You don't need one. Is that clear? Okay, so again, if you can pretty easily get all the data for the entire population, it's not a project. It has to be a project where getting everything for the entire population is impossible, so you have a sample, because that's what statistics is all about. Any questions so far?
I have a question about the confidence interval for two means. Why am I not remembering doing that?
I didn't show you just because I wanted to make sure I got to the project, but I'll show you in a bit, and it's really easy.
Okay, thank you.
Okay. I'm going to just make up some data. I'll just pretend. Just because I was gonna survey you guys, but you only had 2 people show up. If it's only 2 people, it's pretty hard to do any interesting survey and get anything out of it statistically. Sound good?
Mm-hmm.
So I'm gonna make some numbers up. Okay. Last week it worked. We had a lot of people last week. Okay. Just a note, you should tell me the sampling technique. You don't have to spend too much time on it. Just tell me. Okay. Just tell me how you collected the data, what bias might be there. Okay. Any questions on that? Your sample size must be greater than 30. So you're going to end up with 2 columns of data. Each column has to be greater than 30. Okay. Any questions on that? All right, the list of summary statistics, this is a small part of the project, not a main part. Okay, but it's if you're doing, especially if you're doing paired data, it's statistics for the difference that you want, and I'll show you how to get that in a bit. If you're doing not paired, it's still difference that's important, and I'll show you that too. Any questions so far? The standard error is the most important of all of them, and that's the hardest part of the entire project for everyone, and I'll talk about that in a bit. So that should be throughout the entire paper. You should be talking about the standard error. Okay, you should have, now comes the main parts. A confidence interval for the difference and its interpretation. Okay, talk about why you chose the confidence level. The confidence level you can choose after looking at the data and looking at different confidence levels and see which one works best for your particular data. Okay, remember there's a trade-off. If you do 90% instead of 95%, then you're more likely to not be right. But you're going to have a narrower margin of error, smaller margin of error. Okay, don't make this look like just a quick little example that I did on my whiteboard today. You need to do full big paragraphs. Does that make sense? Explain the ramifications, okay, of the mean not lying in the interval. Okay, and that's how you choose what kind of confidence level you use. Does that make sense? Mm-hmm. Okay. Imagine your client looking at the confidence interval and explain what decisions your client would make after looking at that confidence interval. Is that clear? Mm-hmm. Okay. You should do the next big part of the project. Notice I have big paragraphs for this. You should have multiple paragraphs for the hypothesis test. Hypothesis test for the difference in interpretations, that's what we did today. State the null alternative hypotheses. You should do that in symbols and words. Okay. Include repercussions of a type 1 and type 2 error. We talked about that last week. Before you begin talking about the hypothesis test. So the order is important, by the way. You write down H0, you write down H1, then you talk about type 1 and type 2 error ramifications, not just a definition, but what harm will be done if a type 1 error happens? What harm will be done if a type 2 error happens? Does that make sense? Then, based on that harm, you decide on your level of significance. Then you find the p-value using your spreadsheet. That'll be really easy, I promise. And then talk about what decisions will be made based on the results of your hypothesis test. So don't just say, there is statistically significant evidence to conclude that the population mean is big. That's not a project. That's an answer to a homework question or an answer to a test question. Does that make sense? Mm-hmm. I want a paragraph. Okay, what decisions will be made by the client because of your hypothesis test conclusion? Okay, after looking at the p-value, is there reason to conduct a new study? Okay, so in other words, are you satisfied with your p-value? Okay, if you need a new study, that means if you aren't satisfied, that means you had too big a standard error. And the only way to decrease the standard error is to increase your sample size. That make sense? Mm-hmm. Okay. Okay, then smaller things. I went over the main things. Is you should tell me the assumptions you made in finding your confidence interval and your p-value. Okay. Don't get confused between assumptions and conclusions. Okay. Assumption, if you have a small sample size, then you have to assume a normal distribution. If you have a large sample size, you can conclude you have a normal distribution. Do you see the difference? Mm-hmm. So assumptions are probably more like your data collection was not biased. That's an assumption. It's probably wrong, but it's an assumption. Assumptions are always bad. Does that make sense? So a discussion of why your topic and results are important. This should be integrated throughout or intermingled throughout your entire paper, not just the introduction and conclusion. Okay, and a discussion of how further studies can be done in order to develop deeper into the topic. You must put your spreadsheet results copied and pasted into the document. Okay? Let me show you how to do that. Any questions so far? Okay, so here's the spreadsheet, the one that I created. You don't have to use mine, but you should. Okay, because this is all set for this project. Okay, first thing is I have it just on the default, and the default goes to project 1. Doesn't that look like what you did in project 1? Mm-hmm. So we can't do that one. We're going to go to 2var stats. Any questions so far? So we go to 2var stats, and then you're going to need to erase the data that's in there. Okay. And by the way, if you already used the spreadsheet, you have it. If you haven't, then you know how to copy it, hopefully. So then I'm going to pretend like I'm just doing a survey, and I'm going to put in numbers. You're going to have, of course, a whole lot of them, over 30 for each column. So let's suppose we did a study on, we're going to ask 2 questions. The first is, how much time did you take studying and doing your midterm? And the second is, how much time did you take working on project 1? Any questions on that? And I think people spend more time on project 1. Mm-hmm. Sound good? So we're going to do a survey of hours. I'm going to pretend I asked a bunch of people. And I'm going to have 8, 4, 3, 9, 10, 6. And by the way, this is a project 1 data. 7, 9, 9, 11, 15, 2. Any questions on that? And then for the midterm, it's 6, 5, 7, 4, 1, 9, 2, 3, 6, 10, 14, and 1. Any questions so far? Okay, so now, the nice thing about this is you don't have to do anything. All you have to do is move your eyeballs. So first, you have to know, is this dependent or is this independent? This particular example.
I think that's dependent.
Yeah, it's dependent because you're asking the same person 2 questions. Do you see that? Mm-hmm. So there's dependent. Again, you don't have to do any menus and all that. You just look. You have to move your eyeballs. So here's stats for dependent difference. So let me just show you. I can go and copy this. Any questions so far? Mm-mm. And if you're going to use, let me ask, do you use a Word document or do you tend to use a Google Doc?
We used Google Docs so we could share it.
Okay. So
I like working with Word a lot better, but
okay. But either way, it's the same. So that's why I want to emphasize that. So I'll do it with Google Docs. So I need to go to my Drive. Let's give a new doc, Google Doc. And let's say you typed in a whole bunch of stuff in your paper. Isn't that beautiful? And you want to put that column in, you just go Control V. And it says, I want to paste it unlinked. And there you go. It's in. Okay. That's a requirement. You have to do that. Okay. You're going to lose an entire letter grade if I don't see that in your paper. Got it? Because, again, it's essential for transfer. Any questions on that? It's very easy to do. There are no graphs on this one. This is not project one. Don't do a histogram. Don't do a stem and leaf. This is a different project. Is that clear?
Mm-hmm.
And that's it. Any questions on using these statistics? Okay, notice, by the way, in this example, the standard error. How do I always don't know how to unpaste? I have to do that. Nope. Do Control Z. That might do it. I don't even remember what the last number was, 3 or something. No, it was 1, I think. Hopefully it's gone. There we go. Okay, so the standard error is in here, and that's 1.09. Got it?
Okay.
Okay, so in this case, what does that mean? Okay, that means that first thing, the question is hours, right? That means that our sample mean difference might be off by as much as an hour compared to the population mean difference. Okay, I want to let you know the word mean difference, those two words, should be in your paper in many places. This whole project is about the mean difference. Does that make sense? Okay, so is an hour a lot? Well, you might think so. Does that make sense? Mm-hmm. So if you think that being off by a whole hour is too much, then you would say, you know, the standard error is too big, so it'd be better to have a larger sample size. Do you see that? Because a larger sample size reduces the standard error, because remember the standard error is sigma over root n. Bigger n makes the standard error smaller. Any questions on that? Okay, also, if we look at our confidence interval, okay, if we did a 95%, then we get negative 0.316 to 4.48. If we did 90%, by the way, notice they're both positive and everything changes. But then, of course, the trade-off is now there's a 10% chance that the population mean difference doesn't lie in that interval instead of a 5% chance. And are you okay with that? Is that clear? What damage would be done if you tell everyone in the world, including your client, that here's the mean difference, and it isn't there. It's not in that interval. Is that going to hurt people? And if it's going to hurt people badly, then you probably can't go with the 90%. Does that make sense? Then you're going to go 95 or 99. But the good thing about 90% is now we can say that we see that people are spending between 1/10 of an hour and 4 hours longer on their project than they do on their midterm. Any questions on that? Is that clear? Okay, so see how that all works? If you're not happy with that, if you think this is too wide a spread, then you can increase your sample size so you can decrease the standard error. The standard error has everything to do with the margin of error. It's a multiple of it. Any questions on that? Okay, the p-value for a right-tailed test was 0.04. Do you see that? So if it's 0.04, you get to reject the null hypothesis. Any questions on that? Are you happy if you get to reject the null hypothesis?
Yes.
Yeah. So there's no reason to have a bigger sample size when you're talking about your hypothesis test. There might be for the confidence interval, but not on the hypothesis test portion of your paper. Do you see? Your standard error is fine for the hypothesis test because you had 0.04, which is good. If you had 0.06, you would say you have a horrible standard of error because you're really close, but you didn't get it. It's like losing the game by 1 point. Do you see that? Where if you just worked a little harder, you'd have won. Okay. On the other hand, if you get a p-value of say 0.6, you're not even close. So increasing the confidence, increasing the sample size to decrease the standard error isn't going to help. Any questions on that?
Are you suggesting that we might manipulate and change these numbers so that we can?
No, I'm just giving you situations that might happen with your project.
Okay.
Because I don't know what your p-value is going to be. I won't know until it happens. You know what I mean?
Okay.
You won't either. So I'm giving you situations that might happen. And basically the 3 situations are less than your level of significance, slightly greater than the level of significance, or much greater than the level of significance.
Okay.
And if it's slightly greater, then you hate your standard error.
Okay.
Does that make sense?
Mm-hmm.
Okay, if it's less than, you love everything. And if it's much greater than, then you don't hate your standard error, you just probably made the wrong hypothesis. Does that make sense? You're just probably wrong. And increasing the sample size is just going to really, really demonstrate you're wrong, even more so. Do you see that?
It makes it more pronounced.
Yeah.
But we can't adjust our sample size anyway after the fact.
No, but you could talk about if you had more time and money, could you do another study with a bigger sample size?
Okay.
You see that? You can always talk about it. You don't do it, you just talk about it or write about it.
Okay.
Any questions about the project?
If we were doing the independent, would we just skip over to this column to the that's left here?
Yeah, if you're doing independent. Okay, and by the way, the mean difference is also important. That's how much they differed on average. The samples, not the population, but the samples.
Okay.
So, and the mean difference is the same for independent and dependent, by the way. It's still the mean difference. Yeah, so if it's independent, here you go here.
Okay.
Any questions on that?
One question I have, we're going to be looking at something to do with natural resources, and it's possible in a study we can end up with a lot of data.
Right, but don't get so much you can't type it in because you don't have enough time.
Yeah, that's what I'm thinking. Is that going to make it a mess to deal with after?
If you have 1 million data points, you're not going to have time to put it in.
Yeah, not 1 million, but
You have a couple hundred, you might, if you have it on a computer somewhere, you can copy and paste it into the spreadsheet, that's fine.
okay.
But if you have like 1,000 of them, I think that's too much
Okay.
to be reasonable. I don't want to kill you with entering data. I mean, that's just not supposed to be that kind of project. It's not to see how fast you can type. Okay, does that make some sense? And just a note, similar deadline. Here's my suggestion. This week, which is only like another 4 days or so, is you should have your hypothesis, your null hypothesis and your alternative hypothesis. That's how you start all hypothesis tests.
Okay.
What you should do second is you should post it in the Project 2 discussion forum. Strongly recommend before Sunday have that done. Any questions on that? The data collection should be quick and easy. Okay, so after getting your null and alternative hypothesis, I'll look at it. I'm pretty quick at getting back to you. Definitely within 24 hours, usually much faster. After doing that, then you get your data, and that could just be going online and finding data, or it could be a survey. It's your choice. But you collect your data. You should have your 2 columns of data in this case, kind of the opposite of Project 1. But you should post and make sure it's okay, and I'll let you know. If it's not okay, then you got to come up with a different idea. And then you should write up your draft by Wednesday, a week from today. Should be enough time. Projects are a little shorter usually because there's no charts to take up a whole lot of space. So it's usually a few pages less because there's fewer charts. Does that make sense?
Mm-hmm.
You just have your spreadsheet results. That's all you've got. But you don't have a pie chart or stem and leaf and a histogram and all that kind of stuff that takes up space.
I tend to be about 6 pages.
Something like that, 6 or 7. You know, some people have a cover page, and that I don't count that. You know, where all you have is your name and the title.
Okay.
So, not counting kind of the extras, the bibliography if you have one of those, the cover page, if you have a whole page of your spreadsheet result. So it's like 6 pages of writing.
Mm-hmm.
Not 32 pages, by the way.
Yeah, let's hope not.
Okay, that's more writing than you need. Okay, typically around 6. I'm not saying it has to be 6. Could be 9. Some people do 5, but if you have 1, worry a lot. You can't do this project in a page. Okay, even 2 is not possible. Okay, and then I'll look at it. If you get it to me Wednesday, I can look at it Thursday because it's due Sunday. And then you can finish it off. I would recommend trying to have it done by Saturday, completely turned in. It's just like Project 1, where one person submits in your group. And make sure all your names are on it so that I know to give everyone credit. Any questions? And some people are still looking for partners, so if you only have 2, add that person. Any questions at all? Okay, so we're about done with the webinar, but I'm happy to answer other questions if you have them. And if you don't, there's only 2 of you. You can say goodnight, or you can ask questions.
Good night, Casey. Good night, Larry. Thank you.
Okay, good night, Susie. Casey, any questions? All right, good night, Casey. And for all of you who are watching this as an archived video, please don't wait until the last minute to do your project. It won't go well. So try to get your project description done in the next 4 days, and then try to get the draft written by Wednesday, a week from today, and then try to get it submitted, the whole project done by Saturday. So that gives you an extra buffer day in case you lose electricity, for example. I don't give extensions because the idea is you should have it done early. So that's my big suggestion. And next week will almost certainly be Tuesday unless I hear otherwise for the webinar. It also gives you one last day to ask questions before you submit your rough draft. So, all right, good night, everyone. And please post on the project discussion forum or the Q&A forum if you have any questions. So thanks a lot for watching this.
Thank you.